Now that the T-38 is complete, you can see right over there, I'm moving on to the next project in line, which is the Aerofoam T-45, which is this guy right here. And this should be a pretty quick build. I mean, there's some things I intend to change, but in terms of how this goes together, I expect it to be fairly quick. So things first, I'm gonna pull off this wooden platform here, and I'm just doing that so that when I assemble this, the nose section, I just have a clear idea of what is under what and where things are gonna go. You have your package of screws. These look like M4, and your nose section, and in here you can see you've got blind nuts, so that should go on real easy. So I'm gonna go attach this right now. Just for clarity, here's your bolt washer, and then that goes in the plane. That's it. It's nice and tight. Well, it's on there. Now I'm gonna go tighten it by hand. And just like that, she's wearing her nose. So the next thing I think I'm gonna tackle right now is gonna be the rudder / vertical stab. And okay. So first thing I noticed, I was about to put my rudder and vertical stabilizer on, and this is sort of the mechanism that is used to control the rudder, and it sits up sort of like that and moves the rudder back and forth. You can see you've got the teeth, the servo teeth. So I did notice that that was a little bit loose, not as tight as I'd like, and when I tried to tighten it down, the servo was really struggling. So I think this height is just a little too much. So what I'm gonna do is I'm gonna grind it down maybe a millimeter or so, not too much obviously, because I still want the teeth in here to grab the servo. I just want to be able to tighten this down a little bit better and not have it rub on the body of the servo. Basically got my sanding block, got the plastic, and just slowly worked it in every time, checking on the servo head and tightening it down and making sure I don't overdo this. So I've replaced that M3 with a slightly longer M3 with that hex bolt pattern on top and the washer, and between that and actually grinding down the plastic, this feels really solid and still moves nicely. So I don't know if you can see that very well, but now you can see that the plastic piece on top has just a very tiny gap between it and the servo, and that is fully screwed down, so it's not rubbing on the servo anymore. And that was the whole point of doing what I just did. So I'm about to attach the vertical stab, and you can see in here we have these 2 aluminum mounting posts, and there's threads in there. So I just went into my hardware package and found the screws that are gonna go, and these black screws in here. So I'm gonna insert those and tighten this down. Carbon spar. Started here. Very nice. 9? Are you German now, Baba? As always, we have the star of the show. Everything fits in pretty nice, and now I'm just gonna screw those in, and we're gonna call this part done. One down. 2, and that's it. The vertical stab is on there. Okay, so before I install my elevators, I just open this up so I can look in there and make sure that all my connections are nice and tight, nothing is loose. It's always a good idea to not, at least in my opinion anyway, to not expect that the manufacturer has done any of the stuff. So right away you can see so there's impression marks on the foam here, and it looks as though the servo is hitting the foam in the back. And maybe that's not a big deal, but I don't like to see stuff like that. It just makes me unhappy. So what I think I'm gonna do is I'm gonna trim and make room in that foam right there. Because I would rather have the servo just like not have anything binding. I feel like that would be a very easy way to burn out a servo. I have also finished cutting out the piece of foam. It wasn't much. The servo is almost at its limit anyway, but now I'm happy it doesn't bind on anything. So while doing my routine inspection, I found that these screws that hold up the elevator servo, so there's 4 of them obviously, they were fairly loose, so I had to tighten them up. But in the process of doing that, I found that this one up here just wasn't getting tight, almost like it wasn't long enough or it wasn't catching the threads. And so you can see I've pulled off this whole assembly. And the reason is because I looked in here, 3 of these holes have like metallic inserts with threads in them, and that one doesn't actually have a thread on the back. Basically, the screw that was on there was just holding onto this plastic. So I'm gonna pull this apart and try and understand what happened in the back there and fix it before moving on. So. Yep, as I had suspected, there's the metal insert. So I'm gonna hopefully try and insert that back, and then we should be in business. Okay, so a little bit disappointing here. In my quest to find how I'm gonna insert that piece of metal in the back, and it's not magnetic, so it's like brass or something. I eventually broke that supporting piece of plastic, so I have some repairs to do here. But you can see where that threaded insert goes, and there's 4 of them, and this is the one that had come and done. Alright, so I'm gonna get that back together. Okay, so kind of glued it back together. Wasn't too bad. I can always paint over that. But now I'm happy. I think my servo will stay. Yeah, so a little bit of a bummer, but it is what it is. This is a really beefy servo. I mean, it feels heavy, feels like it's good quality, also feels smooth. So afmodel.com servos. It's supposed to be HV, we'll find out. But so far, I'm liking that servo. Okay. So you can see how this dual system works. It's pretty good. There's this piece of plastic here, which houses the aluminum rod that the elevator mounts to. And you can see there's a really thin piece. And if you push the servo, you can see that is deforming that plastic. So look right around here. So that's going to be something to keep an eye out for. When setting up the throws, it would have been nice, honestly, to have that be some composite material, like, you know, carbon fiber, fiberglass, something like a proper tube that is not plastic, or even just bearings supporting, you know, the inboard and the outboard right here. Okay, so now that I'm happy with the insides of the elevator, I'm gonna install my first one, and there's a nice square fitting there that matches this, and you can see on the bottom we've got our screw holes that will attach onto the bottom of these threaded holes in here. So let's go ahead and do that. That's in place. I'm gonna flip the plane over, and then we're gonna screw those in place. So for this section, we have again those screws that are gonna go in there. And the good thing about this is that there's really no way to put this together wrong, because the screws seem to be sized appropriately for whatever surface they're going on. So let's do that. So I'm going to insert this, and you can see I already inserted one, but this goes into an aluminum bar, so I'd like to put just a little bit of Loctite And I'm gonna try to be careful to not get that Loctite on the plastic, but I'd rather have this, you know, blue Loctite in place, just extra security. So, and that's nice and tight right there. Okay, and so the elevator is now installed. I think this is going to need some finessing because you can see it rubs in the back, and also that doesn't seem like much up elevator. So I'm gonna have to figure out what happens here. I don't know if I'm gonna have to trim this on the bottom a little bit because it's definitely rubbing. You can hear that. And it's not reaching the full throw. But a few things that I noted or did. Hi. Is that on my plane, the elevator was rubbing around here. Hi, Bubba. And so what I had to do was grind that down, and also grind the elevator down a little bit on the back and on the front. And that way, I was able to get, I think the manual calls for 18mm deflection up and down, and I was able to get that no problem.
Tell him how he should be doing it.
How should I do this? Like that? Interesting. So the wings are on, pretty easy. There's a spar and a plug-in, and everything just goes together. Really nice fit, and the gear doesn't need to be down, the gear can be up because the gear door is open. You can see those 2 screw holes and the screws that are required, which are just part of the package. So those guys, see if they'll focus. So there's 4 left, and that's for the wing. And pretty much the plane assembly is complete. The wings are on, and I am parting on the servos to make sure everything works. And I'm starting with the slats. Very cool. So you'll see there's a little bit of movement there. You can see that is not tight enough. It's not a big deal, but you know, I like that movement to be just around this ball point here, but you know, keep that tight. So I'm gonna tighten that, and I'm gonna look through all 4 servos. I noticed that, and just tighten that. Not a big deal. So now that's tightened, and I like that. I don't see any unnecessary play in there. Next, I'm gonna do that on the rest of the slat servos. Check to see if they're glued correctly, because I don't want any other glue shaking out there, and just check generally to see that everything is tight, everything is the way it's supposed to be, nothing is loose or wobbly. The plane flipped upside down because I'm going to install the linkages on the flaps and the ailerons. And the beauty of this is that the packaging is all marked for you. So you can see it says flap right there, and it says aileron right there. I mean, it doesn't get easier than this. So I'm gonna install these and show you what that looks like. It's pretty straightforward, so I'm not gonna show it on camera. So a little change of plans. I've decided that I'm gonna hold off on doing the flap. I'm gonna set up my radio first, get the throws that I want, and then install the flap. Okay, and just like that, the ailerons are installed. I'm gonna get rid of the stock back, and I'm gonna get rid of the stock brake controller, and I'm also gonna get rid of the stock landing gear controller, because I am going instead to use one of these that I had lying around, which is the Zycoy LG15. Some modifications are needed obviously to make it work with this gear, namely the stopping points, so how much current to detect motor stall so that we can shut off or detect that gear are locked down or up, and how long to hold that current for. So there's a few things that I need to figure out. But the reason I'm going to use this is because it's very programmable, and that's what I want. In addition to that, it has a gyro inbuilt in here, and you can not only like steer the jet correctly, but you can also use differential braking to stabilize how the jet drives and when it lands and takes off. So this little guy is packed with features. I mean, it's not cheap. It's almost like $200, so I don't recommend that you go out and get rid of your stock electronics because I think they work okay. But I have this stuff and I like precision, so between the smooth flight and this, I think this jet should fly really precise. I think I have some good settings to start with when it comes to using the LG15 Zycoy on the T-45 landing gear. I'm going to deploy the gear. Okay, so it looks like about 210 milliamps-ish on the downswing. Let's see, going back up. Maybe a little more because I'm actually lifting the gear. Let's see. So 200 milliamps-ish going back up. So that doesn't seem like a lot. So that gives me sort of an idea of how much current the nose gear is pulling. Obviously, I think in flight, that's going to be a little bit higher because there's going to be air resistance hitting the gear. So I'll keep that in mind. But why this is important, so why is that current value important? Because if you read the manual, it tells you that different gear require different settings. And those settings are going to be found on page 2 under motors. So you can see it requires you to enter the maximum current that those motors can handle, and it's explained in the manual. So right now I have it set to 1 amp for the mains and the nose, and then the maximum time for retracting, or that time that the current should be flowing, is set to 10 seconds, which is fine. Now this unload time is interesting because what that is, at some point it detects that it stalls and the current is detected that it's spiked up. So that tells the controller that the gear is at its endpoint. And what that unload time is saying is how long to back off. In other words, the longer that time, the more the screw backs off. And so I just set it to 100 milliseconds as it is in here, so that's the default, and that seems to work. So these are the settings that I'm going with, and you can see 1 amp is significantly higher than 200 milliamps or 210 milliamps that I measured on the gear. But I did this because this is a max, and I'm expecting that there will be more current required once you have this thing flying and there's resistance on the gear. So both gravity, weight of the gear, and air. So here's my gear. Gear up. I'm hoping this will be a much better system for my gear. So looks like it works well. Everything sequences correctly. Gear's up and locked. Gear doors close. Bringing gear down. Also, you'll notice that I have made my nose light. Gear actually turn on and off. So you can see that's off and gear's going up. I think it comes always on. I wasn't able to figure out a way to make it go off with the stock gear setup. But anyway, easy fix. I just bought one of those Turnigy receiver control switches and put that on my landing gear channel, wired it with my landing gear channel, and it works great. So this is the stock canopy or hatch or whatever you want to call it, and I have trimmed the edges a little bit. You can see like towards the back here there's still a little bit of lip hanging out, like right there for instance. But let's see, if I try to stick this in the jet, you can see it doesn't quite want to sit there right. So let's go to the front here, and I'm trying to push it down. So there's a lot of resistance, and it's clearly not sitting right. So I suspect this is similar to what I had with the L39, where the plastic is not properly glued to the foam. So what I'm gonna have to do is pull out the foam from the plastic, test fit the foam, and if anything like the AF-L39, which is what I found out, that should fit in there, and I'll just have to re-glue the plastic on the tank. So you can see that is a pretty clean fit. Here, let me pull it off. So that's off, and if you look at the edges, this just clicks into place real nice. So that tells me that the plastic bit, which is this guy, was just not properly glued. What I'm gonna have to do is use some foam tack, and then with that plastic sitting in place like it is now, trim and then glue this in place. Check it out. So I have trimmed the canopy and glued the plastic onto the foam in place. So you can see that fits perfectly. Canopy's down, everything is good. I'm happy. The stuff I used to glue that is just foam tack. What I'm doing right now is pulling out the tanks from the T-45 and just going over, making sure that my tubes are not perforated or anything, adding safety wire to the barb and make sure it does grab onto a notch in the barb, if there's a barb. And then I'm not gonna be all crazy about this. I'm not gonna add barbs, I'm just gonna add safety wire to those as well, and to the front portions as well. So I'm going to show something that I found that I did not necessarily like. So here's what comes out of the UAT, basically your intake plus filter. And you can see I have yellow Tygon on there, which is not what came with the jet. What came with the jet was two of these. So this tube is a little bit narrow. So they had one tube go in like that, and then a second tube go over that. And so it probably works. So it was like something like that in here, and then that went over the barb. And it probably works fine if you wire wrap it, but I didn't like that. That seems clunky to me. So I took all of that off and just had, I have some Tygon tubing that happened to be the right size. Stuck it in there, made sure that the section between the metallic pipe and the actual filter is fairly short so it can't really kink on itself, and wire wrapped it. And I like that better. One piece, really nice, not going anywhere. So just something I thought I should mention. Again, all of these things tend to be a preferential thing, what you prefer. This is what I prefer, so I did it this way. Thing I'd like to show. So on my tube that goes from the bottom tank to the top, how it came was with this sort of in there, and the tube would go in there. But that's a pain in the butt, because if you want to service, and you got to take this off to see what's underneath on the plane. I'll show you once I put it in. It's a pain. So I cut that and installed a Festo fitting, so that way that sits like that, and I can take this off. So just small little things real quick. So I'm gonna put Velcro on the bottom of this piece of wood, and I'm gonna use that to sort of be the first point of securing the tanks. The jet comes with the top tank secured with Velcro, which then this stuff grips onto a bulkhead in the back here. So I'm just gonna do the same thing for the bottom tank. I'm gonna add some Velcro on the bottom, and that's gonna stick with this. So when I slide the tank in, it's gonna have some of this Velcro gripping on. So we'll see. Okay, so the wiring on the T-45 is pretty much done. So I'm gonna just turn on my radio, and obviously I have my key fob to turn on the jet. Let's see.
Volume 100.
Okay, radio's on. Let's turn the plane on. Plane is now on. You can see that all the surfaces work. Okay, so wiring is done. I'm very happy with how this came out. I still need to check control surface throws but I'm pretty much happy with this. So now that the T-45 is complete, I figured I'd do a quick view or overview of how I decided to do my wiring. So starting at the front, you can see I have one battery here, and that's a 2S2200, and that's going to be used for the landing gear. And as we move forward, we have my LG15 landing gear controller and brake controller, which I set up to work with these gear. And then you have my Smooth Flight SF16. And to get the CG at about 178, which is right around where these dots are, I had to push my batteries all the way back. I guess an extra weight of adding this stuff in the front. And so I'm gonna have both my SF16 battery packs. These are 2S2200s. And right in here is where my Life 3S Life pack is gonna sit, and that's gonna drive the turbine. And you can see the connection for that battery is here. So all of my connections are down here. You can see there's 3 of them. So one battery, second battery, that's for the Smooth Flights. And then the last connection down here is for the landing gear. And as you can see, I don't know if you can see that in there, I have my remote controller, so I can turn everything on and off remotely. And that's what that thing down there is. Moving on to the back, nothing interesting here, just your K85 turbine, and just pretty standard. I measured the gap between the end of the pipe, so that's where the bell meets the actual pipe, and the end of the tail cone is about 1 inch, so I think that'll work. And I added all the stuff, so I glued these guys back in, glued the fins in the back, and she's pretty much ready to go. Okay, so I'm about to run up the T-45 for the first time. I have both tanks full. Let's see if we can show that. You can see the fuel level pretty much full. So I'm going to use my phone here and set a timer and see how long full tank of gas would last. I'm going to simulate flying conditions.
Ignition, no data.
that is time. So we are at 10:55. I'm gonna rotate this. Okay, so that was about 10 minutes and 55 seconds on both tanks at, full throttle mostly, and a mixture up and down. And so that gives me an idea. With both tanks full, I'm going to be expecting around, I'm going to say like 8 minutes, anywhere between 8 and 10 minutes.